This week we're looking at probably the most important part of the mathematics curriculum that you're going to encounter. The working with numbers probably occupies anywhere up to 80% of teachers' time. Whether that's a fair representation or not is not up for discussion at this point. But suffice to say that working with number and working with the number strand is probably going to dominate your work in mathematics education. So what do we mean? There's a number of key aspects that you need to do as a teacher of number. I would strongly recommend that you read through your book and read through the other articles that are there to really get a sense of this critical part of the mathematics curriculum. One of the key things you need to do when students start to come into your context, whether that's an early childhood setting or whether it's the school context, it's really critical to be aware of the number knowledge that children bring to school. This will vary extensively depending on the background of the child and their immersion in number through their family activities. Many students, young children, will have been walking down the street with their parents and they'll have a concept of odd and even numbers because of the numbering in the streets and so on. What you do need to do is recognise what young children have in terms of number knowledge and then shape them to be the socially legitimated knowledge that we value in schools. So coming to understand where the children are coming from and then building on that knowledge so that they start to align with what we see in the national curriculum is really important. So some of the things that you will be looking at in terms of developing the number component of the curriculum are counting. Students need to be able to be rational counters, and there's a lot of work will in the area of counting. They need to work with big numbers, and big numbers are those numbers that are 1,000 and above. They also need to understand patterns within numbers. Coming back to where our very first week, they need to be thinking and reasoning mathematically with numbers. They should be creating visual patterns with numbers. They also should be recognising groups with some sort of automaticity. So we call this subitizing, and subitizing simply means being able to show a collection of objects so that they know that there are 2, 3 or 5 in that collection without counting them. They also need to develop number benchmarks, and these are usually around 5 and 10 because we use the base 10 counting system. They should be aware of basic number facts, so these are their addition facts, their number family, so 2, 3 and 5 belong as a family because 2 plus 3 equals 5, 5 minus 2 equals 3, and so on. They also need to understand the effect of various operations on numbers, so that generally in the early years of schooling they come to understand that if you add numbers they generally get bigger, if you subtract they generally get smaller, and similarly with multiplication and division. However, they are going to encounter at some stage that it's not always the case, because when they start to add negative integers the number will actually get smaller. So there will be counter examples as they go through school. But in the early years, those general ideas are what we're looking for. One of the key outcomes for the early years of schooling, in the early years curriculum, is that students need to have good number sense. They need to have an intuitive sense of number. What does it mean? What do the operations do? And so forth. So number sense is critical. So what is number sense? What we're looking for are relationships between numbers. So those are the things like number families, so that they come to understand that 2, 3 and 5 tend to group together. 5, 3 and 8, for example, are a group of numbers. So when I add numbers, if I add 3 and 5 I'll get 8, but if I've got 8 and I take 3 from it I will have 5, those sorts of things. They need to recognise the relative magnitude of numbers, so that 8 is actually a bigger number than 5, and 80 is a bigger number than 8 and it's about 10 times that size, those sorts of things. And they need to recognise the relative effects of operating on numbers. So that's their number sense. They also have what we call a lot of pre-number activities. So these are activities where we're looking at classification, so they can start grouping, because if they can group, before they can count objects in a group, they need to be able to classify those numbers in a group, and they need to be able to do patterning as well. And there's a lot of patterning activities that they will do. So there's simple patterns like an A-B pattern, growing patterns, A-B, A-B-B, A-B-B-B, those sorts of patterns. And also we need to be fostering subitizing, so recognising how many are in a group without actually counting. These are really important skills for the students to know, and your job is to actually teach them. So counting. There's a number of stages in counting that you need to be aware of. The first stage is the rote counting. So these are verbal counting patterns where kids can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all it is it's an auditory pattern, but it's not actually counting. It's a series of words. Similarly, you'll hear kids going 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. They're saying the number words in the correct sequence, and that's important. Very early they might go 1, 2, 3, 7, 6, 5. What we're looking for with rote counting is that they can say the numbers in the correct sequence. From there, what we're looking for then is the children to start doing point counting. So that means they start to do, as they point to objects, they're counting in the rote counting fashion. So they're pointing, going 1, 2, 3. What often happens in this stage, the student's starting to develop the rote counting skills, but they may not actually have 1 point to 1 count. So they might have 4 objects there, they touch the first one, they go 1, 2, touch the next one, 3, 4, 5, and so on. But they're starting to develop the idea of pointing to an object and counting. The final stage is rational counting, and this is where we're aiming for the students to finally go develop into. So what they start to do is each item is only counted once. So this is what we call one-to-one correspondence. So as they touch an item, they only count it once. The counting is actually in the correct order. So as they're counting, they're going 1, 2, 3 as they count each object. They also know that the order or the start point is relevant. So whether you start on the left hand side or the right hand side, it doesn't matter. So long as I count for each object and have a count, the start point is actually irrelevant. They also need to know that the last number that they counted to, so if there's 7 objects in the collection and then they go 1, 2, 3, 4, 5, 6, 7, as they touch the last counter, they know that there are 7 objects in that collection. And that's what we call cardinality. So that's what we're building for, is for children to be rational counters. The other part of the early number work is the idea of conservation of number, and we talked about theories of learning. We talked about Piaget's theory of stage development, but Piaget also had a number of other key ideas, and they are things the conservation of number. So if you have a collection like the orange squares that are there, there's 5 squares there. Young children will often be perceptually seduced into thinking when they see the green counters that there's actually more of them because they take up more space. But in actual fact, if children are able to conserve number, they know it doesn't matter how the numbers are displayed or the objects are displayed. 5 is 5 is 5. So in this case, irregardless of how long the second collection is, there is still only 5 counters in that collection. So conservation of number is really important. Young children can be seduced into thinking there's more if you scatter the same collection out over a larger area. So conservation of number is also a key attribute that you're looking for and you're looking to develop in your children. The other thing that we're looking for are counting strategies. So once children are able to count, we're then starting to get them to count on and to count back. We might start counting on and counting back from particular points, as in 1, 2, 3, 4, but at some point we're also going to start at another point. Count on 3 from a start point of 4. So they have to go 4, 5, 6, 7. In that process. Similarly with counting back. So what you can see when they're counting on and counting back, we're actually starting to get the children ready for addition and subtraction. And skip counting is also important. So 2, 4, 6, 8. What we're starting to do with the skip counting at this early stage is getting the children to see a pattern and being able to skip count, and in many ways this is the precursor to multiplication. So counting strategies are also very important for you to focus on. The other thing to look at are number benchmarks. We have a base 10 counting system, and the two number benchmarks that we're always looking for in developing are around 5 and around 10. We often use frames such as the one here, where we have a 10, what's called a tens frame, and in that tens frame we actually have two sets of two rows, and we can see that in the top row there are 5. If the children are able to subitize, they should be able to recognize with an automaticity that there are 5 in there. They should also be able to see in the second column, in the second row, that there are 4 in that second collection. What that means now is if the children have got their counting skills, they can count, so we're not looking for that anymore. We're starting to want them to have these benchmarks. So subitizing means they can see there's 5 and there's 4. What they now can start to see is that in actual fact that the 5 and the 5 is a 10. So they're starting to see a lot of patterns coming out in their numbers. So you might ask children, what can you tell me about this collection? So they might be able to say, well, 9 is 1 less than 10, or 9 is nearly 10, or 9 is almost double 5, because they can start to see the relationships of 9 with the benchmarks of 5 and 10. So benchmarks are important for you to develop as well. Now there's different types of numbers that you also need to be aware of, and this is also important because some numbers we can do operations on and others we can't. So cardinal numbers are the ones that we work predominantly with in mathematics. So these are the numbers that tell us how many. So if we've got a collection of 2, we know that there's 2 apples, 2 oranges, 2 bananas, 2 cars in that collection, and we've got another collection of 3. Now we can operate on those numbers. We can actually add them together, so we've got a total of 5 cars. However, there are 2 other sorts of numbers that you need to be aware of. So ordinal numbers tell us the place or the location of a particular object. So either the boy came in first and the girl came in second in the race. Now these numbers you cannot operate on. You cannot say if the boy came first and the girl came second that the dog came third, because you've added 1 and 2 together. You cannot operate on ordinal numbers in that way. Similarly, we have nominal numbers, and nominal numbers are naming numbers. So if you've got a racing car, and it's got the number 9 painted on the side, the car is, you could call it Jack or Fred or Betty if you like, or you can call it 9. So these are numbers that are just naming numbers. So in NRL teams, for example, the number on the player's back actually tells you the position of that player. In AFL, the players just have a number, and that's their name. So rather than asking where Eddie Betts is, you know that Eddie Betts is number such and such, and that's his number. Similarly, horses in a race are now, again, with nominal numbers, because they're naming numbers, you cannot do operations on those as well. So you need to be aware of these different sorts of numbers to provide the right opportunities in your maths teaching. The other part of the number strand that we focus on in the early years is numeration, and it's important to understand that the Hindu-Arabic system that we work with is an important system. One of the big advances in moving from, and you may remember that back in your school days where you had to use Roman numbers, and adding Roman numbers became quite tricky. The Hindu-Arabic system represented a very significant change and advance in our mathematics, simply because we had 9 digits if we were using the base 10 system, and we had a placeholder 0 which said there was nothing in that place. That was a significant change. So what we have got a base 10 system, and so we only have 10 digits, and all numbers now are a combination of those 10 digits. The position of the digit actually represents its value. So if a 1 is in the ones column, it represents 1, but if the 1 is in a hundreds column, it actually represents 100. So we have to be very cognizant of the number and where it is located in that number system. This is also a multiplicative strategy. So the value of the digit is actually a multiplier of where it is in the place value system. So in the number 435, the 4 is in the hundreds column, so it is multiplied by 100. The 3 is in the tens column, so it is multiplied by 10, and the 1 is in the 5 is in the ones column, so it is multiplied by 5. So it's a multiplicative principle of our number system. The other part of the number system is that it's additive. So to find out the value of all of these numbers, once we've done all the multiplication, we find that in the number 435 we have 400 plus 30 plus 5, which brings us to a grand total of 435. Now our number system works very much like the odometer in our car. So as the number rolls over, so we go 1, 2, 3, 4, 5, 6, 7, 8, 9. When I get to 9, I'm now going to go to 10. So that flicks over. So my 9 rolls over and my 1 then becomes a 1 in the tens column, and I go back to 0 and I start counting again. And then when I get through those numbers and I get to 8, 9, it's going to roll over again, and then in my tens column my 1 will roll over to a 2. So every place counts. So if you think of our number system working like the odometer in your car, it tells us how our recursion within our number system works. And again, that's a feature of our Indo-Arabic system. Very, very dissimilar if you think about what it was like with the Roman system, where it was really about naming numbers. One of the things that you have to do, and this is often probably the most difficult and most challenging part of teaching maths to young students, some students really struggle to grasp the concept of place value. So we need to spend a lot of time on it. Now, earlier on I spoke with you about the Dutch system. The Dutch system doesn't teach place value until almost the end of primary school. Their argument is students need to get good number sense, and then place value is informally introduced. However, in the national curriculum and many Western countries, place value is introduced towards the end of the early years of schooling. We are bound by that, so we teach it in that way. So you need to create a lot of experiences for your students in terms of place value, and there's two models we use. We use proportional model and non-proportional models. Now, proportional models actually show relative size. So much like our odometer, we have ones. So if we're using bundling sticks, such as popsicle sticks, once we have 1, it's 1. But when we have 10, we actually have 10 ones, so that bundle is bigger. And then when we have 100s, it's a much bigger bundle again. So the size of the bundles is proportional to the value of those bundles. In contrast, we have non-proportional models too. Now these are models whereby if you were using bundling sticks, when you got to 10, you might swap those 10 bundling sticks over for a red stick. Now we do a lot of this with unifix blocks, for example. So when you get 10 ones, you trade those 10 ones for a different colour counter, and then that can sit into the tens column. And when you get 10 of that column, you trade that for a hundreds counter or a hundreds block, which is a different colour again. So it is a non-proportional model. We also need to have the students, as they're doing all of these counting activities and bundling activities around place value, they need to be creating a table or a record of those, and we use the use of T-tables. T-tables are a diagram that is a horizontal line and a vertical line that intersect, and you have them set up as columns. So you might have tens and ones, and the students are recording how many tens they've got and how many ones they've got, and then they start to see if they've got 3 ones and 4 groups of 10 or 4 non-proportional tens. They've got a 4 there, so they can see they've got the number 43. We also need to do a lot of grouping and regrouping with MABs. So for example, they may have they may have got their 9 ones, and then they throw the die and they get another 6. So now they've got 15 ones, so they have to trade or exchange 10 ones for a tens block. So grouping and regrouping is really important in the in developing the sense of place value. So all of these activities are building towards the number sense and numeration of our students.